Hello everyone, my name is Roos Zaalberg from Aarhus University in Denmark, and I'm presenting my study on the genetics of infrared predicted milk minerals. So we have our cows and they produce milk, and our study is looking at mineral concentration in milk. And we think this is relevant because milk minerals have been associated to health in cows and humans and to milk processing, such as cheese-making properties. Currently, we're using methods which are expensive and slow at measuring milk mineral concentrations. But studies have shown that we can use infrared milk spectra to predict milk mineral concentrations. However, questions remain regarding the genetics of infrared predicted milk minerals, such as the heritability and underlying QTL. And this brings me to the aims of our study. We want to predict milk minerals with infrared milk spectra, we want to estimate heritabilities for infrared predicted milk minerals, and to find QTL for infrared predicted milk minerals. We started by building prediction models using more than 250 Danish Holstein cows and more than 260 Danish Jersey cows. We had one morning milk sample for each cow, for which we had milk spectra, 10 milk minerals, and we built prediction models for each milk mineral using PLS regression. We used a one-herd out validation method to validate our prediction models, in which we would exclude one herd at the time and predict the phenotypes based on the remainder herds. For our genetic analysis, we used a different population of over 1,400 Danish Holstein cows and more than 1,700 Danish Jersey cows. For each cow, we had up to 10 milk records, for which we had milk spectra, the infrared predicted milk minerals, and 50K imputed genotypes. We then used a longitudinal model, which consisted of some fixed terms such as parity and the lactation curve, and random terms such as herd year season effect, additive genetic cow effect, and permanent environmental effect. Our results show a moderate prediction for magnesium and sodium, a good prediction for calcium, and an even better prediction for phosphorus in milk. And we also see that the heritability for infrared predicted phosphorus is relatively high. And when we take an even closer look at the genetics of infrared predicted phosphorus, we can see that there is a QTL on chromosome 1, which harbors the gene that has been related to phosphorus in milk. And even though the population that was used to build our prediction models was rather small, we still think that these are promising results for including infrared predicted milk minerals in breeding programs. We conclude that milk spectra are good at predicting calcium and phosphorus and moderate at predicting magnesium and sodium, and that infrared predicted milk minerals have a moderate heritability, and that QTL revealed that there is important information that is hiding within milk spectra. Thank you for listening.